Hello everyone. This is podcast number 2 for our robotic podcast. I'm Paolo. I'm the host today, and today we're going to talk about a dog design from Ting from Germany, who is in the meeting already, and he's going to talk about this project, Ting, and how long did it took, and why he was building this. So, yes, please, Ting, you can just talk about yourself and why did you build this robot, which is amazing.
Thanks. So, thank you for the introduction, Paulo. So I'm Ting. I'm from Taiwan, and I sort of moved to Germany like in the past 1 or 2 years. Actually, now I think about it, maybe a bit longer. But basically, I moved here to. So I'm actually like an experimental physicist. So like I'm doing like a postdoc over in here. So in this academia world, I guess postdoc is basically like contract workers and whatnot.
Wow.
Yeah. But my background is not related to the robotic at all. So actually, I have to in order to build one of these, I have to build like completely from scratch. And yeah, like my formal knowledge, yes. So I did do quite like. So for experimental physics, you basically anything that as long as you can achieve the goal, you learn whatever is needed. So I do know a little bit of the coding, a bit of the electronics, and a bit of the use of the motors. But otherwise it's it's a completely hobbyist project.
Wow. I mean, that's kind of impressive. I mean, I guess physics, obviously I guess you study biomechanics, and I guess you know the basics of electromagnetism, but yeah, building a robot is quite different, right? Like it's there's a lot of new skills that you have to learn, and electronics, PCB manufacturing, and so that's interesting. How did you find it harder than expected when you were doing this?
Yes. And actually, one funny thing is that back when I was in the school, the mechanics is actually the subject I failed. It's the only one I failed. So, yeah. So I think from my experience is that you just really slightly change a field, and this field just open up vastly that you have to learn so many things from the beginning.
Yes.
And every step is a challenge, I would say.
Yeah. Great. So, tell me, like, why did you pick up a quadruped? So for like design, is it for flexibility or because it's very popular? All these robot companies are doing that. Yeah, and the size, and what was the objective of building this essentially?
So, how do I put this? So for me, this robot Doggo, or like this four-leg robot is more like a goal of some sort. So, for me as my interest is actually to collect a lot of these. Back then when I study physics, I like to collect all the physics, like different aspects of the physics, and to mathematics, and to statistics, and to like electronics.
Yes.
And then since robotic, actually previously I also bought one of those spider robots like on Amazon for assembly and whatnot.
Okay.
I think these days they are also quite available.
Yes.
But then I realized just building it, I really don't know the detail in there. Yes, I can follow the manual instruction and whatnot, but I really don't know what's inside and what's driving this robot to work. So, but one of the thing is that I think robotics really covers a lot of different aspects, not just electronics. It covers like the mechanical part, and especially before I build this, I have a 3D printer that this 3D printer I bought like on Black Friday on Amazon and whatnot. And then I think 1 year after I bought this 3D printer, I have no idea what to print anything for. And then I realized, robotic is quite a good place to go and then get all the different part of it.
Yeah. And Did you design in CAD? Like, what tool did you design it first, or it was more like trial and error? Like, what was the process? Yeah.
So I actually designed this in the free CAD.
Okay.
Because it's free. I was I think for like for the other ones like the Fusion 360 and whatnot. From time to time I have access to them, but from other times I don't. So since I'm also moving around, as you see, I'm Taiwanese and now in Germany.
Yes.
So I sort of choose now one of them that I know is completely open source. FreeCAD has some quirk to it though, but
Okay.
But my thought really is just build like I think every parts that you see here, like all these small parts that you see those, they are done like piece by piece. So they are basically brute force sort of an idea. Basically, the first thing I print out is that, okay, if I want to hold this cubic shaped servo, what do I need? I just build the simplest thing that has the right bolts hole to like place them into. So that's how it come to be, and then it slowly evolved. And I think from this design you can still see there are a lot of not completely optimized parts.
And did you also calculate the linkages, because you have yes, so you have is it 2 degrees of freedom per leg or free? I can't really tell from the picture. Like 2 motors per leg? Oh no, it's 3 motors per leg, right? You have the hip.
Yes.
Yeah. Okay.
So it's 12 degree of freedom.
Okay.
For like robots. So I have 12 servos in total.
Yes.
Yeah. So this linkage, to be honest, I have to say, like at the beginning when I want to build one of these with 3D printing and whatnot, I sort of just want to learn and have a project to finish. I actually tried the Stanford popper design first. I was actually going through all its tutorial. And then I realized that they have very special motors.
Okay.
And their motors actually also designed to be here.
Okay.
But they have a very special, like small, strong motor that's put here. But after reviewing quite a few, especially inspired by this Spot Mini and whatnot from Boston Dynamics, they really don't want to keep any mess on the leg.
Okay.
So that's why there's a sort of a linkage. That can such that you don't need to have another heavy servo on the part. But of course, there are people who design it even better. They put this particular servo also on the body, so you don't have to lift it up. Right now, this one is sort of floating. So what this particular servo, I don't know how it's. Maybe I need a better picture, but like this inner servo actually carry a second servo, and this servo carries this. So,
yeah, makes sense.
But once again, that design, the even more advanced design, is actually much more delicate. It requires very specific linkage that's not. So linkage here you can see it's just a straight line. So that when you walk, they sort of just turn exactly in the same synchronized way. But in order to have this particular servo also on the body, you need some curved linkage. And yeah, since I'm
of course,
like
yeah.
you can see, my mechanical engineering is not the best out there.
Yes.
Cannot, yeah. So
Go for the simple
like
line. Yeah.
exactly. Like this gear design and whatnot is
Yeah.
yeah,
Yes. Yeah.
it's a bit over my head. So
Yeah.
I'm just choosing the simplest path to reach
Makes
this
sense.
particular.
Yeah. And what motors did you use? Are they VTEC or Dynamixel or something else?
So yes, so this model that I'm using is actually called Dynamic Soul.
Okay.
I think it's the cheapest version of the Dynamic Soul, but still they are much more expensive than the RC servos. I think one of these is 40 to 50 ish.
Yeah.
But I must say, the torque I think is 1.5 to 2 newtons, times meter ish.
Yeah.
It's actually not the strongest out there, as I realized. But one thing that's really good for these, though, I think at the beginning I also don't know if it will be successful. But I think having these dynamic servos, they are very well documented, at least in terms of porting to servo, and there's so many functionality that are already available. You can tune its PID if you want, but it already has a PID implanted, and
Nice.
you can also read out this current, and you can even
Torque.
have a passive. Yeah, exactly.
Yeah.
For a current for the torque, exactly.
Yes.
And it seems to be, although I also never work on the RC servos, but this one really does seems to have much fewer quirks. So you don't actually, it almost just work out of the box. So I think it's really nice.
Yeah. Okay. Yeah. So you have the servos, and then you have, what is your control board? Is it like a Raspberry or ESP? Yeah, all the power electronics.
Yes. So my control board, actually I can also
show some other pictures.
Slide. Yes. So my control is really simple, I would say.
Yes.
You can see that so these power boards, they are basically come directly from the dynamic soul. Okay, and then you have all these 12 dynamic souls. So the only thing that's really different is this Raspberry Pi 5 as the main board control, and then maybe the batteries, the 12-volt batteries. Actually, this is a battery for these boats, like the racing small boats. I suppose it was pretty popular. Actually, I have to say, my second brother actually did help me quite a lot about the ideas. And interestingly, he studied mechanical engineering.
Yeah, okay.
So there was quite quite a help for me that he exactly. He filled the void that I have in my knowledge.
Yes. Yeah.
So after that, I think the only thing is to actually also power the Raspberry Pi with a battery, it's just also a very custom. You can buy it almost anywhere. Kind of a step-down converter, and then power it this way.
Okay.
But one of the things, though, one of the special things that need to be happening is that in the end, this particular controller from Dynamic Soul, it does not have enough cables to connect to both of these at the same time. And once you connect to both of these, it also float on the same voltage. So in that way, I think the only thing that's need to be DIY is to buy one of these cable, cut them in half, and make the white cable out of it.
Yeah. Makes sense.
So, but when I do that, of course, one thing I was a little bit afraid is that you know it
It's
could it
catch
could
fire.
catch on fire.
So
Exactly.
that's a
But-
bucket.
yes, exactly. I mean, so like to my knowledge, it should be okay. But yeah, I never know. That's why I have a specific because all those batteries are they are like lithium batteries, and they cannot be easily extinguished. So I have this
Yes,
like
yes,
bucket of
yeah, yeah,
sand.
yeah.
Yeah. But in the end, it actually works out really nicely. I think these power boards are quite nicely designed.
Mm-hmm.
Of course, for the more professional people, uh, the professional robotic developers, I would say, like in
Mm-hmm.
the university and whatnot,
Mm.
they would be capable of designing a PCB, which I'm,
Yes, you don't have the time and
yeah. Exactly.
yeah,
I mean, technically, I may be able to pull it off with half
yeah.
more years, but it's
Yeah,
also could be a learning experience.
yeah,
But maybe I'll do it next. I think there are too many things to work on at a time, so
yes,
my choice is just to work on one thing at a time.
yeah,
Just,
yes, makes sense. Yeah, so two lipo batteries. So one is for the like, is it so one powers the Raspberry Pi? Ah, no, so you have one
uh,
regulator for the Raspberry Pi, and then you have two individual, one for six, so one for each of the groups of
yes,
motors.
yes.
Okay, okay.
So technically, so for these kind of servos, compared to the RC servos, they can also support the so-called daisy chain. So I also have one over on here.
Yeah.
So you can have like two
Yeah. So yes,
connectors.
yeah.
Yeah. So you can connect one side and then come
Come
out to connect
go to the next
another.
one. Yes, yes, yeah.
Yes, yes.
Perfect.
But the delay, if you connect all 12 together, like in a long daisy chain, there will be like milliseconds delay, and
Ah,
those delays will be for working robots. The yeah, controlling wise could be problematic. That's why it's sort of separate into
To-
like four different
yeah,
daisy
yeah,
chains. Yeah, also more evenly distribute across the legs.
yeah, yeah, yeah. So is it like, do you? So I guess it depends on the gate. You will do left and right as two separate daisy chains per B, so that they don't, they don't take enough delay, something like that.
Right now, I think it's right now I think they are more or less even because now all the four legs are identical. So I think
Yeah.
with this I don't see significant delay.
Okay, okay.
Of course, there's a wire that's longer to the back leg as compared to the foreleg. But
Yeah, okay.
maybe I should have designed it better too. But so far, I think it hasn't been a main problem.
Okay, okay. Makes sense. Okay, so you have enough power, and then so you have the Raspberry Pi connected to the serial for the servo commands. And so the question now is, what does it run inside the Raspberry Pi, right? What's the control strategy for the robot? And yeah,
Yes,
because
and I would say this, So I'm running. I don't quite have a slide for it.
Okay, okay.
But basically, I'm running the so-called the ROS, the
Oh wow, yeah.
system.
Version 2 or 1?
Version 2 on Jesse.
Okay,
Yes.
okay, yeah.
Yeah, so in fact, so I went back to check my GitHub just to see how long I needed to develop this fun like nothing to the end.
Yeah.
I realized this ROS tool. So the whole overall project, I think it takes 1.5 years to develop. But then I realized I spent one whole year just on the learning the ROS.
That's
So it's
I've
takes some
yes.
patience to build up, I guess. But
I've seen
guess it's worth it.
a lot of complaints, and it's incredible how it's an old system, right? That's the only one that you can use, And it's incredible how difficult it is to learn. And I've heard, I mean, not just yourself that you come from another field, but like when I was learning it, and or all my colleagues, they all came back with the same feedback. This is so hard. Like, why it's so hard to use it? And like, yes, it's incredible. I mean, and even I think most of the commercial, well, not all of them, but I know that some of the commercial robots they do have ROS. And I guess it's the only one that has enough history to be, bug free, relatively bug free, stable.
Exactly.
But yeah, it's hard.
Exactly. Actually, there's one thing I also probably should mention, as it could be a bit controversial in terms of developing this, is that this project is also the first time I heavily use the large language model for advices.
Okay.
Actually, this is the beginning of this is that I was talking to my office mate, and he's also very interested in the large language model.
Okay.
I was saying, my next project I want to develop this.
Yes.
And then I should heavily rely on because at the time, like 1.5, 2 years ago,
yes,
not a lot of people are using LLM. It seems to be like a niche, and it's kind of controversial, I would say.
Yes, true.
So exactly, this is also the project I kind of want to test out its power of that, because I also didn't get into it in my own work.
Yes,
but then might as well try it on the hobbyist thing and then see what happens.
Interesting.
So basically, I think the LLM is really helping me a lot in studying these ROS. And at the beginning, I also ask, because every time I make a choice, they could be multiple different choices. And I was also afraid of a situation I got a little bit into every one of them, but not deep enough to eventually develop into a system. So I did ask it multiple times, and LLM will almost always direct to the ROS.
Okay, so it's always What any other options he was suggesting you? What was he?
It was for a while ago, so I didn't completely remember. Sorry.
Okay.
But of course, I think a lot of the developers can, in principle, develop their own. Like, for example, I think quite a lot of people know how to write this inverse kinematics code, which I mean technically would also be a cool project, but I decided to heavily lifting on this move it.
Move it.
From the,
yes. Yeah.
So
good. Okay.
So I think at the beginning I really don't like the fact that the ROS has so many different modules, like different sections of it to control just slightly different things. But I think now I find it's technically not a bad choice. Yeah, but you are right. When I was studying it, like every single part is like, why do you do this? Yes.
Great.
Yeah.
And because you build the geometry and you kind of knew how to make it walk or move, but you didn't know the inverse kinematics and maybe how much torque do you need. But then at some point, did you put it into a simulator or some form of testing to make sure that it could have enough torque? I guess the motors are big enough, but how did you play with the kinematics and figure out So
this is actually a bit of a history in some sense. So at the beginning, the path is really not so clear for me. So my first thoughts before, while I was studying ROS, before any hardware was developed, my thought was I will study this control theory textbook.
Yes.
Oh my, I mean, if you read that and you want to formulate every single thing in mathematical form, not in code, in mathematical form, it's it's nine impossible to even understand what's going on, like a little bit in between when you just want to just do simple inverse kinematics.
Okay.
I mean, I know such a thing exists because I read the textbook, so in that part I'm fine. But it's a matrix, like somewhat matrix multiplication, but in between you have to solve other things. I think in the end it's really it's really a bit tough. So, yeah. So my thought really was after scanning through this, I didn't go into detail of each of the calculations, especially like putting in on code. But after going through, I thought maybe I just need to see how it works in the hardware.
Okay.
So at the beginning, I also technically I can ask the LLM directly, but it's also at the beginning. I didn't rely on it too much.
Yeah.
I just thought, let me just build one legs.
Oh, okay.
So I bought 3 servos.
Okay.
And then see how it works. And then my second brother, it was him who told me to use this the linkage.
Yeah.
So like to use it correctly, like where to put the bearings and what kind of bearings and whatnot. So I can even show you some of my prototypes.
Yeah.
So if you can see here.
That's a lot of wise, man. There's a lot of wise there.
Right?
Okay.
But you can see on the left.
Yes.
They look on the outside. They look very much similar to what already I have, right?
Yes.
But in the detail, very different. Look at how long these legs are.
Yes, they are long.
At the beginning, I didn't know what to expect for, so I just said I like a cat draw some legs, and then the dimension I can fix it later.
Okay.
And I also don't know why I want to specifically have this spherical shape design at the very end.
Okay.
I think even the previous version it was like 2 times as wide, which is completely unnecessary. And then at this stage too, because I'm also like an amateur in 3D printing, it was also like 100% field. So it was super heavy. And it's not able to do a lot of things, like not even standing up properly.
Oh wow, yeah,
Yes.
yeah.
And then I afterwards I realized, maybe it is now I can get it all sort of working, right? Maybe it is time to update it. So I asked LLM what kind of leg length toward the like the body weight. So I mean, one thing that's I would say good about this my sort of going free kind of approach is that at least I roughly know how heavy this guy is going to be. Because now I can just directly measure it. Yeah, so it's roughly 3 kg, and I just ask LLM like for 3 kg robots, what kind of so basically the essential thing is these two lengths. So the I also don't know. As you can see, I have no background. I don't even know how to code it. But okay, sorry, my arrow was on the wrong thing. So maybe here is it right. So this length versus this length. That's on the ground. So I think accordingly they should be roughly the same size. And every time it's larger, it will require more torque.
Yes. Yeah, the momentum increase, right? Yeah.
Exactly. Yeah. So especially in the typical standing up position, I think they said the stand up is roughly 135 degrees, so like 45 degrees deficit. But you have an angle like this, and then you can sort of estimate the torque like that. Even very interestingly, at the beginning, I really was. Even though I study physics, I should believe in this calculation.
Yes.
But at the beginning, I really don't trust standing it up higher is actually less torque. Although it's technically make a lot of sense. All my physics teaching is telling me that's true, but intuitively I still don't think it's true. So at the beginning, I actually have a much look at this. So this was
Oh, the
my
angle.
previous. Yes, this angle was my previous standing angle. It was way too short, so that's why. Sorry, it was way too like close together.
Yeah. Yeah.
And that way, it actually used significantly more.
Yes. Yes. Yeah.
So.
Okay. And
so
yeah.
sorry. One last thing.
Yes.
As you also mentioned. As for the simulation, yes, I did do some simulation on the gazebo.
Okay.
Because that's also
supported
part of the
ROS, yeah.
Yes. But eventually I realized that I like the LLM also suggests me to do a manual gate first. So in that sense, I didn't go into it as much because of how often I change my setup, like my robot dimensions, and in the robot world, there's this URDF file, right? So it basically tell you the relative position of each of these parts. It's nice that I did make all these like sort of module. So basically, what I did is that only at the beginning I put everything in CAD. Okay?
Yes.
But then the next step, I actually put piece by piece of the components I need on the URDF.
Okay. Yes.
And then build up the rotation one by.
Yes.
And then I realized supporting a URDF, a CAD, a gazebo, every time when I do the change,
yes,
is a lot of changes. So in the end, I only focus on getting the URDF correct. But for the future development, of course, I would say the simulation will be essential. But right now, I'm just trying to find like the most optimal dimension for it.
Yes.
And once that's settled,
makes sense. Makes sense. So yeah, I've seen this problem in like various project where like either you copy a design that has already been optimized, so you can scale it down and you can say, oh well, Boston Dynamics or this inverted legs design, they're pretty optimal in that sense in terms of, well, you would hope, maybe I'm wrong, but like in theory they spend enough time to measure the optimal torque, standing torque and dynamic torque and whatever, and then maybe you just scale it down and you do some calculations. Okay, mine is smaller, I have smaller motors, roughly. Yes. That's the way you do it. But then the big question, as you say, like when you move between CAD and URDF and simulation, like every time you do a change, you have to go back and forward again, which is a pain because none of those tools do this URDF export properly, right? Like I've seen even Onshape and the most expensive one, like AutoCAD, Fusion 3D, the URDF converters, they don't work very well, right? So like sometimes the axes are off, they are not in the same position, then like that's the problem, right? And this is a big problem for everyone, not just yourself.
I would say especially when you use FreeCAD.
Well, yeah, I would say
sometimes changing the geometry itself is already oh no, what the heck is he doing? Okay. So FreeCAD it really need to get used to. It's kind of funny that you have this like you build. You can actually see this is a sort of my design pattern. Yes. Is that I built like cube, I patch it up and I dig a hole.
Yes, like subtraction. Yes.
So it's really composed of all the most basic geometry out there.
Yes. Okay? Yeah.
But because in FreeCAD, really, if you you do this series by series, right? Basically, you define a shape. You make a lift up, so that is now a board. Yes. And then you dig a hole. You draw a circle, then you dig a hole, something like that, right? Yeah. So if you do this several times, let's say you have like 9 features on your on your body, and then you decide to change the force feature.
Oh.
Sometimes it doesn't work. Sometimes you have to redo all of them, and yeah. So in order for that to work
Ouch.
to work on the automatic URDF like formations.
Can consume it.
But still, though, I'm really appreciate that at least there's a
at least there
CAD
is some
software
software you can do it.
Exactly.
Perfect.
Right. At least you can do it.
Yeah.
Yes. So I can also show you like like my more hardware kind of prototyping approach is result like this.
Oh.
Yes. So you can see that a lot of the thing is one dimension is wrong, and then I basically have to change again. So
there's a lot of dead parts over there.
Exactly, and a lot of them are like almost identical parts. I just need to shift slightly. So a lot of time I didn't quite optimize on the CAD part. I basically just print it out and see if it works. Yes.
I have the same problem when I do prints. I do everything, do all the calculation, and then there is something I didn't consider. It's like, it doesn't fit for 2 millimeters. And
yes. So I think for me, because I'm also working like after work and whatnot, right?
Course.
So usually I can do only one or two things at a time. Like sometimes I just let me not do this calculation. I'll just change this a little bit. Yeah, the other part is still wrong, yes, but let me just change this, print it out, and see if it fits properly. Yeah.
Okay. Wow. Yeah, that's part of the. Good. Okay, so these are the parts, and so that you put it in ROS and then in Gazebo. Did Gazebo have already a walking generation routine for this kinematic chain? How did you do that to make it work?
Unfortunately not. So I think the simulation will be my next steps.
Okay.
It will sort of be essential for my next step as well.
Yeah. So now you can control the legs, I guess. You can do all the controls, Okay.
I can even I can even show you that in my current like URDF setup.
Yes.
The robot is actually upside down.
Oh, okay. Is he on purpose?
Exactly, because to avoid it like hitting the wall directly. So the current gate is doing upside down. But I mean,
so it's to kind of so you can test the motions of those legs. Yes, makes sense.
So physically, you can. If I mean, like once you have the gate ready and you can do that upside down. Your physical robot doesn't have to be upside down.
Yes,
so you can flip it over and then it now works as intended.
Okay.
So my next step actually also is not just on Gazebo, but I also successfully port at least once to the Isaac sim. In that it has a geometry. It can move manually, servo by servo, so it doesn't have a walk gate and whatnot. But I'm thinking, I think my walk gate is also not perfect. And I think there are a lot of reasons that I also don't want to make it completely perfect, because there will be actually maybe if you mind me, like this may be a little bit of the next step related, and I can sort of explain why doing it all manually at some point will be just a complication of no return. Yes. So basically, one of the things I learned, every time when people see these walking robots and then it sees my robot like sleepering, right?
Yes.
As it moves, it's not completely people will think it's not as efficient, because if you have sleepering, then you are not moving forward. Right? But as it turns out, if you want to put friction on your leg and then you make it walk, it requires a much more precise gait. Because once you put your legs on the ground and you have a relative motion, especially when you have four legs.
Yes.
If it's lifted up, you can have any slight change of motion. That's fine. Once you're on the ground and your gait is off sideways,
Yes.
that will give you a huge force, not on the ground because you cannot move.
Yes.
It will force the other side
Yes.
of the leg to turn in a unpredicted way.
Interesting. Wow.
And then actually with that, it already broke off several of my legs directly. Just walking like 2 seconds later, the leg snaps right off. Yes.
Wow.
Yes.
Yeah. So not the motors,
So-
but the actual plastic, you mean? That's
yeah. So the 3D printed part, yes, it's also
okay, maybe it's
not
not super robust with the infield.
exactly.
Yeah. But
I
yeah, makes sense. I mean, if you can achieve less breakage with slipping, why not, right?
yes.
Interesting.
And yes, and I have to say, like, not even for the walking, even for just a typical standing up, right?
Yeah.
Right now, my
this?
standing up, yes. Right now, my standing up is actually very lazy, I would say. It's just ROS is really nice. You just say, okay, you want to have a final settings, and then we'll calculate the trajectory for you.
Ah, so you start from the beginning to the end. Okay.
Yeah,
And it's
yes.
going to do the.
But
Okay.
if you want to do it properly for standing up, that doesn't break your leg without sleeping, you need to keep your foreleg exactly at the same plane.
Yes.
While standing
True.
up.
Yes.
Yes.
Yeah.
And that calculation alone, yes, I mean, if I spend a few more weeks, yes, I can do a calculation to do that all nicely, yes. But yeah, do that also for kneeling down, for the other slide motions. Oh, it's a lot of work.
Wow. Yeah.
But what's really breaking the straw is so the next steps. What I'm thinking is to put an IMU on
Yes.
top.
Yes.
Basically, so I don't know what's the acronym for. Just show you
Inertial
my profession.
measurement unit. Yes.
Okay. Yes. Thank you very much. Yes. But basically, this device can help me understand the state of the robot in a sense that let's say my robot body is like this, if it turns and whatnot.
Yes.
Because there's I think the most important one for me is that it has a arrow that's point to the center of the
center of mass, right?
Yeah.
Yes. Yeah.
At the gravity.
At the gravity.
direction.
Yes.
Exactly. So it's a center of mass location that points to the gravity.
Yes.
So let's say if your dog is tilted, then you can do an algorithm to tilt it back.
Yes.
Okay?
Yes. Yeah. I've seen some videos where people, either in simulation or in real life, they put it on their thing and they stand steady because you can calculate the gravity and then you can keep it. Yeah. Makes sense.
Yeah. So if you want to walk up a slope, yes, that
would be important.
the thing.
Yeah.
Yes.
Otherwise, Ross thinks is not flat, right? Is not totally flat one. It's not doing that.
Yeah. So ROS on its own. I also have to say my current project right now, the cubic robot current version, it has no feedback system.
Okay.
Although it has all the features available from the servo. So this smart servo really can give you a lot of information. But I haven't been using them at all.
Yeah.
So that's why my next step will be to use those information as well as the IMU to do this. However, there's one thing that have to really think about it is that if you are balanced while standing up, okay, this one you can do it very quickly. If you are balancing while walking, then it's a completely different story.
Ooh.
So basically my current code, every time it does a gait calculation, so basically you do a walking, like you do this walking.
Cyclical, yes.
Exactly. So my code has loop sort of calculation. Every time after a loop, it does the next calculation.
Yes.
Okay.
Yes. Yeah.
So that means with my current design, the IMU feedback
Uh-huh.
can
Like
only
come
be done,
between these
yes,
loops.
between the loops.
Ah, yeah, that's another
Yes,
problem. Yeah, yeah, yeah.
exactly. And if I want to do this manually very fast at every single motion
Mosh.
location,
Yeah.
I need to recalculate what the desired next step is. And I was thinking, oh my god, no wonder like before AI nobody does this. Holy cow. Yes. So
Yeah, yeah,
yeah.
yeah, yeah.
Yeah. So that's why I think my next step really is to go full simulation
Mm-hmm.
and then do the
Reinforcement learn.
reinforced
Yeah,
learning. Exactly.
and learn this
Exactly.
policy. Yeah, yeah,
Yes,
yeah,
yes.
yeah. This is.
Uh,
I
and
mean,
in
yeah,
fact,
yeah.
yeah.
I've seen back in the days when I was doing industrial robotics, and I did all the mathematics for industrial control,
Oh my
which
god.
I kind of, but that was my course, so like, I cannot say I don't like it, right?
Yes, yes.
But
But
for static robots, it's relatively easy, right? I remember I can even do it by hand, right? So like all the directive. I mean, yeah, of course now.
still full respect, full respect.
Yeah, that was fun. The problem was when you move into when this robot move, because every time it moves, right, you change your reference point. And I
Yes.
remember all these lectures that were like, okay, so if I have a robot with 4 legs, it's very complicated. So what do you do when you're in midair? And like it was, as you say, like impossible. Maybe now with GPUs you can simulate, I mean, in real time, but it was just impossible to do like from this step. And something is happening because it's not touching anything. It's dynamic, right? And then oh, this leg is touching, so we recalculate everything from this leg, right? And like
Yes, yes.
it was insane, and people do that in video games for doing animations, right? So this rigging and animation. But if you notice how they walk, it's very like not robotic. How can I say? Like sometimes the character float like this
Yes,
because it's very
exactly.
hard, right? It's very hard to do that. It takes
Yes.
so you
Yeah.
you sort of simplify, right? Like
In video games, they only need to make the figure shift forward and do somewhat walking motion,
Exactly.
and it looks
Exactly.
okay.
Exactly.
But
Exactly.
in real world, your legs have to actually physically touch the
Touch.
ground and then propel
Yeah.
forward.
Yeah. Yeah. Yeah.
I
It's-
also really have to agree because at the beginning I was learning I think this control theory is sort of the the classic one that you learn. Man,
Yeah.
those are really tough. So I really respect you guys to be able to do that.
Yeah.
But
Yeah.
one thing I got super confused when I tried to think about that and apply on the robot
Yeah.
is how to think of these so-called endo effector.
And the factors.
Okay.
Yeah.
Yeah.
Mm.
So usually, I think in a common setup is the robot arm. You have a defined origin,
Yes. Yes.
and then you have the end
The hand.
effector is basically the head of the
Yes.
of the arm
Of the
right?
arm. Yes.
So you can
Correct.
do it like this.
Yeah.
Yes.
Yeah.
That's actually why I set my robot upside down in the in my URDF.
Yes.
Because it's basically try to reproduce for an endo factor.
Yes. Good idea. Yeah. Because there is no
Yeah.
moving, right? You don't have to do all those
Exactly.
calculations. Yeah.
Because my mind just blows thinking about if this origin also change along with when you change this gate, like which one is changing is what? Yes. So
Yeah. But I think even if people from traditional theory would have solved that fast enough, the problem is, as you say, when you go into real life, you have so many things like rubbles and rocks,
Yes.
and like redoing all these calculation costs is just like it's just insane, right? Like you have to
Yes.
know where the rocks are, and I think that's why this RL took off very quickly, right? Because then
Yes.
like you don't need to know any of that, right? You just have a neural network that based on the observation does a sequence of actions, right?
Exactly. And I think this is really what I'm trying to get into because
Yeah.
this is really, I would say, it pops out like in the past only a few years.
Yeah.
To my knowledge, though, is
Yeah.
technically when I bought my previous spider robot, it was already like 5, 6 years
Uh,
ago.
yeah.
It was a time when these Spot Mini
Oh
first
yeah,
come
they
out.
come out. Yeah, yeah,
Yes,
yeah,
and actually that's sort of the first reason why I go to it, and I was
yeah.
a bit hyped. That's why I kind of already that
Ah,
time not
yes.
raws, not
Oh,
very
it wasn't.
consistently.
Mm,
Yeah,
mm, mm,
yeah.
mm, mm.
But that was completely manually coded classical gate,
Yeah,
if I
yes,
remember
yes,
correctly.
yes. Yeah, a lot of
Uh-huh.
these robots, they are kind of open
Yes,
loop, what I call open loop, right?
yes.
There's some motions.
Uh-huh.
Maybe I think I saw some really interesting ones where they do have the
Uh-huh.
sensor and like they sort of guess if you are flat and they
Yes.
generate different motions, but
Exactly.
they
They
get
have all the sensors
yes,
to calculate their feedback, but you have to physically code the response for
yes.
every of the feedbacks. Oh
So
my.
yes, it's yeah, yeah,
Yes.
old generation versus
Uh-huh.
new generation.
Yes, and I
Yeah,
would
yeah.
say at the time there's I think you can check the like the YouTube history as well.
Mm-hmm.
There's a lot of the like four-leg robots popping out during that time. I think the Stanford Popper was also
Yeah.
popular during that time.
Yes.
And
Yeah.
then I think afterward there was a long, long sort of silence. And
Yeah.
then now I think there's a reinforced learning again, which
Yes.
I also super want to learn.
Yes.
Because I have to say, like in our field as well, sometimes we we don't jump directly to the most hyped thing.
Yeah. Uh-huh.
We usually wait until it's somewhat mature before we
Yeah.
because they're like in academia there are always some hype things, but some of them goes on for a long time, and some of them not so much.
Yes.
And
Yes.
yeah, and AI is really, I think at the beginning, from the academia point of view, we thought, it's a okay tool.
Yeah.
But once the
Yeah.
LLM happens, it's really quite, quite next level kind of development, I
Yeah.
would say.
Yeah. Yeah.
And then that's why actually 2 years ago, because of this LLM,
Yeah.
basically what I realized is that first of all, I kind of want to start learning AI. But maybe even like a slight history is that previously I also tried to learn AI.
Uh-huh.
Basically, I learned everything up to deep learning, and
Uh-huh.
I sort of stopped. So
Okay.
everything up to these so-called support vector machines.
Ah, SVMs. Yeah. Okay. Yeah.
Back then was the best thing out there.
Yeah.
And I also still remember this like Stanford professor claiming that this support vector machine is able to feed any single function out there
Yes.
with its capacity.
Yes.
Yeah,
Yeah.
I think at the time I was thinking, yes, all these classic, like people are hype about this and new
Yeah.
thing.
Yeah. It
No,
is.
the-
Yeah. Yeah.
Yeah.
Yeah. Yeah.
I thought all these classical ones, they are sufficiently powerful.
Yes.
Until I prove it wrong, like when the LLM comes out, it's completely different piece. Yes, yes.
Yeah. Yeah.
But then after then, I realized I think the next development, which I'm really optimistic about, is really to port these the AI things into the physical world.
Yes.
I think from my my own work side, we also really value this so-called software to hardware interface, and I really think this time is really the time for like
So
the robotic will make AI even a bigger thing. So that's
Yeah.
why.
So, yeah,
this is
yeah.
a good project to encompass them all. Basically, that's
Yes.
why I start building this.
Yeah, it makes sense. So, as we go to the end of our podcast, what's your prediction then? You seem very positive about the future of robotics. Do you think we are going to have, let's say, house robots that fold our clothes, clean the toilets? What's your prediction? Is it like 2 years? Some people say 2 years, some people say 5 years. What do you think?
I would say 2 years will be
Uh,
a bit tough.
uh.
I think so. In my opinion, is also I'm not expert, so
Yeah, no,
I
but you know, you're building one, so you already see the problems, right? Like
uh,
all the kind of yeah.
yes. So I think the AI so far deal with the walking gait
Hmm.
like no tomorrow. I think since this Asimo,
Yes, from
the,
Toyota,
after
yeah.
Asimo, there's a huge desert of the
Yeah, yeah,
development, the
true.
walking
Yeah,
gait.
that came out and yeah, it was
Yes,
nothing. Yeah, yeah,
yes. And when AI comes out,
yeah.
almost I would say also one of the thing is that I think in China right now they're developing them like very quickly,
Yes,
and I
yes,
also
yeah.
see like in Europe is
Uh,
also a bit not so much.
yeah.
That's why I kind of want to build this so that it
Yes,
can be sort of open source. People get interested in
of
more.
course. Makes
Um,
sense.
but I think this walking gait thing really almost completely solved.
Yeah.
So I think
Yes.
the next thing, as I think many already probably have already mentioned,
Yeah.
is to do the like to use the tools.
Yeah,
So
manipulation.
yes, with sort of the hand.
Mm, mm.
So I think the idea really is that especially the two-leg walking robots. It's a bit out of my league right now. I know some
These
people
are yeah.
are very talented to do it,
Yes, yes.
but
But
yeah.
yeah, they
So
work. Yeah,
yeah,
they've
yes.
done yeah, interesting
It's
things. Yeah.
incredible things. But I think two leg is really very necessary because we
Mm.
build our environment
Yeah.
around
Around
ourselves.
ourselves.
So two legs is really the easiest to
Yeah.
navigate around environment.
Yes. Yeah. Yeah.
However, I also realized that we also build the tools around ourselves,
Mm.
like all these size of like carbs and whatnot,
Mm.
perfectly fit for us to handle,
Yes.
and we have
Yes.
hands.
Yes.
So basically, I would say once the hand is
Problem
sort
is.
of completely figured out that it's able to
Oof.
use
Yeah.
tools,
Tools. Ooh.
then
Yeah.
it will.
That's.
I would just say even like the most basic thing that human can do, just grab one paper and grab one scissor and cut it. If that can be done, I think a lot of them
Yeah.
will pop out. It will pop out so quickly
Gosh.
because a
Yeah.
lot of the thing is really once you get this manipulation done,
Yeah.
like you can really start using all the tools that you make.
Yeah. Yes. Yeah. So, what's next for your robot?
Uh-huh.
So we're going to wait until you develop the gate essentially in RL. So you're going to give us
Uh-huh.
an update, right?
Yes, yes,
Perfect.
yes. I think once that's basically my next goal.
Yes.
So my thought is that so there are a lot of things I also want to do. For example, the lidar and
LiDAR.
like Ross has a really nice nav2 system,
Okay.
which I
Okay.
actually one of the thing I haven't learned yet.
Uh-huh.
But for now, I think I want to try the shortest path
Yes.
to get the RL
Yeah.
because I think for now that's also interests me the most.
Yes.
And I can also say a little bit about this too. So, for example, my this IMU
Yes.
is essential for RL. You cannot have an IMU without it.
Uh,
Sorry, you cannot have an
I
RL
always.
without the IMU because you won't get the reward function.
Yeah. True. Yeah.
Yes. You can rely on the servo, but I heard
No,
it's
but
super tough.
Yeah. Yeah.
12
Yeah.
servos,
Yeah.
like what kind of function do you want?
Yes.
Right?
Yeah.
So
Yeah. Yeah.
IMU will be important,
Yes.
but so as I actually figured out, I was trying to use a lot of this work that people have previously developed. Like for example, this Champ.
Mm-hmm.
It's one of the ROS one software. I also recently just realized it's ROS one, so I probably cannot quite use it.
Okay.
But its IMU is also published by a so-called node.
Node.
As
Yeah.
Yes. This it may be a bit abstract concept, but I would say that like this. So the node, the upgrade frequency, I think will be hertz level. While the IMU, although not the fastest that I have right now, will be 100 hertz.
100 hertz, yes.
Yes. Hertz level like feedback for training, I think it's going to be very difficult. So my next step is not just to use the IMU, but also to incorporate in ROS such that it has this 100 hertz of the feedback rate.
Yes.
And then I can put it on the Isaac sim.
Right.
And I also heard that's a completely different beast.
Yes.
I'm a bit nervous, but at the same time, a bit excited to learn about.
Yeah.
It will be very different from what come to this gate. So
yes, brilliant. Okay, well, we'll be waiting for your project updates, and I'm going to put your link in the YouTube video so like people can go and watch your GitHub. So thank you for all your experience and sharing all your failures. Going to put it there.
Sounds good.
Perfect. Okay, it was very nice to see you, and have a nice day, Ting.
Thank you for the interview. You too.
Perfect.
Have a great day. Ciao.
Ciao.